we move now to the next manufacturing process, which is metal casting. And again, you can have combination of these things. I remember somebody asked when we were in injection molding, is it only used for plastic? And I said, no, even we have metal injection molding, which you will see today is sort of similar to injection molding. With casting, when I say metal casting, it doesn't mean it only applies for metal, but this is going to be the focus of our lecture. But there might be, you may see some weird parts that they are like plastic, but made by casting. Okay. So let's say I will show you. Okay. Yeah, let's start with these two examples. On the right, you will see a guide pad, which I will explain in a moment. I elaborate a little bit in a moment. It has been casted by me. And the reason that I put it there, because I studied casting like in depth. I knew every formula and everything about it. And I thought it's easy. I thought, well, melt some metal. Of course, you need a lot of fire and a lot of heat, but melt it and pour it into a die or into a mold, and then you will get the nice shape that you want. That's all it takes. Let it solidify, and then all it takes. But it was very miserable when I the situation was miserable when I cast this one. A lot of smoke coming out of these melting. It was an alloy of babbitt, or alloy of aluminum and copper, and which I'll talk about. I believe I talk about it, about babbitt. And then the part that I got at the end has nothing to do with the one that I had planned in mind. It has been some machining on it, this hole, but there were shrinking, like the geometry was shrink. There was some crack in it, and yeah, and it wasn't a good experience. So what I'm trying to say, what you learned today is just some very, very basic, but it's way more to that. And next week again, on Thursday, the guy who comes to talk to you, he's an expert in casting, and he's going to talk about it a little bit more and the challenge around it. So the second one, so I have, I believe, one babbitt here to show you. So this is not the one that I made. This is another one. This is for some reason, okay, the video becomes slow. This is the basically a guide pad babbitt, which made by casting. And the babbitt basically is a soft material. When it is in touch with like a steel, which is a saw, this is a portion of a saw, we make sure that it creates the bearing that we want. It has this oily surface, and it is soft, and it creates a nice bearing, like bearing basically for what we want. The second one, that image that I showed you, was something, maybe with black background. It cannot be seen very well. Maybe let me put a white background. Maybe better, a little bit color. Yeah, because now it's better. It's a antique lantern, old generation. I brought it with myself. It's iron and cast long time ago. I don't know when, but probably it's more than 200 years ago, at least. So anyway, many old things made by casting. Let's move back to the slide that I had. Yeah. So the guide babbitt that I told you, let's say you have a saw guide, something like that. So I just want to give you an idea how this guide pad works as just one application. So the babbitt is like on this schematic is over there, And like here on this image, this is like where the babbitt goes, basically. This is the arbor, and these are the saws where they sit. On each side of a saw, there is a pair of these guide, which create that bearing for this system. Yeah, we put the saw on there, and then the second one shows clearly the two sides of the, basically the guides, and the guide pads are inside these guide arms. And obviously this is where the cutting happens. The saw rotates with high speed, and these guide pads provide the, basically the bearing that we want. All right, so that's the guide pad. But the reason that I mentioned that it's the manufacturing method, main manufacturing method for guide pads is by casting. And sawmill is a large industry, and they cast these guide pad in an average sawmill, maybe 100 of them per day, because they wear out very fast, and every 4 hours they need to change it. And basically, without casting, any other manufacturing process that they use is going to be super expensive. So let's move to the second example. And that one is basically a espresso filter holder. And this is the question that I have. And in a moment, I will show you the actual espresso filter. It is from my coffee machine. So the good things teaching from home is I can find things at home to show you without me needing to carry stuff around. So this espresso machine, let's say this is the question we want to answer. Why it is metal, it is an aluminum alloy. Why machining is not suitable for that? Let me show you the actual part. So that's the coffee espresso filter. Let me get rid of these. Okay, so maybe also black background is not a good idea. This online teaching, I guess, or I'm not sure, make a student's life easier, but it made most of the teachers' life more difficult. So in the past, it was easier in that aspect for me to go to the class and show this stuff, but now I have to come up with some way to show it to you. All right, guys, so this is a question for you, and I want you to think carefully. Let's say you are in an interview and somebody shows you this part and says, well, this is a filter holder for an espresso machine. Of course, I can remove this filter. Okay. And later I have to make sure that I wash it before I make my coffee. Okay. So it is hollow and some plastic inside, but the focus is around, and the handle is, of course, thermoset. And the focus here is on this metal part. So the question for you is, why do you think we cannot make this by machining? Any idea welcome. Let's imagine you are in an interview and you have to come up with something, because in an interview you cannot just say, right? Why do you think? Go ahead, Jesse.
Manufacturing costs, just because this probably has to be mass produced, so it would cost a lot to have a bunch of machinists make this.
That's valid point. So as Jesse said, if you're making thousands of that, then machining, of course, is not suitable. What else?
Probably
it's got a. Oh, sorry. Go ahead.
I was just gonna say it's probably due to the complex shape of it. Like the milling machine probably can't get to all parts of it.
Yep, that's also true. As Ahmad pointed out, look at these features. Like here is hollow, here like that. really, how do you want to machine it? If let's say you put it like that and you machine it, it's not possible to get underneath of it, right? You have to machine it one way like that. Let's say a complex milling machine to create this contour for us. And then you have to flip it. It's going to be a headache. And almost maybe one filter is going to cost thousands of dollars. So what else? Puri, you want to say something?
I was going to say exactly the same thing, that it's a complex shape that's hard to mill from all one side.
Yep. So as our friend mentioned, it's true. It's complexity of the shape. And also, as Jesse said, the mass production doesn't make sense to go with basically machining process, but more the complexity of the shape, because if you want to machine these things, it's going to be a headache. And also, it's not symmetric, right? It's not symmetric that I can put it on a lathe. So I have to do it by milling. Let's say that pocket milling that you learned, but this time a positive, let's say, shape. I have to mill it, and it's going to be very expensive and basically crazy to do it by machining. So, but why casting? Okay, so casting, well, it's a process which can be used for mass production. The quality is relatively good. It's relatively cheap. We'll discuss it a little bit more, and I elaborate more on that one. And also it can go from different sizes, like this jewelry on the left. And this is me, and I'm a tall guy, relatively tall, 185, not bad. So, and this is in Granville Island. Probably if you might have passed this one. Ship propeller made by casting. Next time, maybe you should take a selfie with that. I just took this photo because of this class. When in the summer I was there. It's not now. I'm not that brave going now with a t-shirt out. I need to have a warm jacket. Remember, I came from warm area. So, and then this one, just to give you an idea, look at this building over here. This is the 4th floor, but of course we are in a different view. It's this one, when I check, it's 4 meter diameters. This one 4 meter diameter, this 2 meter diameters, and this one is like 15 millimeters. So anyway, my point is it can be used for making tiny, small things like jewelries to gigantic parts like these propellers. Historically is important. The main reason that the White brothers were successful was the fact that they use aluminum for their engine block, and they use die casting. So one positive note for die casting. And I guess you guys know Wright brothers. Money-wise, that's important. Only I-beams, just the I-beams, in average 10 million tons of casting for I-beams. So it means it's a gigantic industry. It's really an old age, basically manufacturing. So 6,000 years ago, it's a long time ago, right? And who knows, maybe there are even older than that as well. Like this, on the left, this bronze statue of somebody. I forgot, to be honest, but maybe later I can, on Wikipedia, I can find more details. 4000 BC. Then you come to these, like every day, probably if you're walking on campus, not on campus, everywhere in streets, you see these red or yellow fire taps and pipes. And then it comes to these complex valves, nuclear, or these blades, or this V-shape engine block, modern V-shape engine block, and these also turbine blades. They are all made by casting. So you see from 6,000 years ago, still a hot topic and a hot manufacturing process. It was more like history, but I can see the time is up now. So yeah, let's just finish this slide and then we'll continue next week. But I elaborate more on this one next week. Casting, there are many ways to do casting, but these are the most common and the three most common methods. Sand casting, die casting, and investment casting. Investment casting is another name for lost wax casting. Sounds like a weird name or fancy name, lost wax, but that's another name that people call it. So in general, sand casting, if you want to make bigger, large parts, rough surface, so you don't care about the quality of the surface, and you don't care too much about the precision, you go with sand casting. Die casting, if you want a little bit more accuracy, and the surface quality is important for you. Many parts in a car, they are made by die casting. And investment casting, if you have a complex part, if it has complicated curvature, internal curvature, then die casting is the method. And we're going to talk about these next week and some engineering analysis around each of them. All right. So that's enough for today, guys.